All right. Welcome to another installment of Math Basics. Mr. Best, question that was raised. Okay, I got a question here, and it's a percent of change. But, oh my goodness, there's algebra. What do I do? What does this mean? So, okay, students putting on the puppy brakes. You don't have to worry about that because we already went over specifically how you do a percent of change. Every time you do a percent of change, you always do the same procedure. You always start with 100%. Scope the problem out. See if you're increasing your 100% or decreasing it. They tell us right here at 77% here, you're going to discount. The word discount means sale, and sale means subtract. So what we're going to be doing is we're going to be taking 7% away from 100, and that's going to give us 93%. Now, again, we know what we got to do. Every time you have a percent, you got to make it into a decimal, and you do that by dividing by 100. So now here is my magic multiple. All right. The multiplier. It's what we talked about, 0.93. So now we have to apply it and we have to use it. Look at my choices. Before you just go out and take a stab, before you guess, use some of your prior knowledge about math. Take some of these answers and eliminate them because they're nonsense. For instance, look at letter C. We talked about combining like terms when we started our pre-algebra unit. Combining like terms taught us that we could always add a number to a number. We could always add a percent to a percent. We could add an A to an A B to a B, an X to an X, a Y to a Y, but never, ever could we ever add or subtract two things together that were different. You can't add a letter to a percent. You can't add a letter to a number. You can't add a number to a percent. When you take a 1A and a 2A, you can add them together and make 3A. But when you take 1A and add it to 1B, it doesn't add up to be something different than that. They cannot combine together because they're not like terms. So when I take a look at these answers that are here, this guy is having you try to take a letter S. Now also remember, you can always drop a 1. Anytime you ever have a variable term here, a letter that has no number in front of it, you can always drop a 1 in its place. But it's having us take a letter, 1S, and subtract a number from it. This is absolute garbage. And so is letter D. Letter D is making us do the same thing. It's taking a number, the number 1, and we're subtracting a term that has a letter from it. Again, rubbish. Now, last but not least, we're choosing A and B. Now, I know some of you are probably looking at it saying, yes, we know the answer is going to be B. And it is going to be B. But here's the reason why. If you look at A technically is mathematically correct. It just doesn't answer the question. Because now if I want to, if I drop a 1 in front of S right there, this becomes 1.07S. That's what that simplifies to. And what that essentially means is when you add, adding has nothing to do with a discount. The adding part would be there if you were, let's say you were adding a tip to a restaurant meal, or you were adding tax to something that you buy. That's the reason why you add. This is a discount. This is subtraction. So A, even though it's mathematically correct, it doesn't answer the question because it's showing you what happens when you would add to the 100%. We subtracted. So now, the other thing that you're going to notice is when we did the math the way that we learned about percent of change, and we started with 100 and we worked our way back, the decimal value or the multiplier that we got was part of my problem. When I got that 0.93, it was part of the solution or of the answer that we were looking for. So sometimes these questions are as easy as that. You know, we may look at a problem and it may seem a little bit more difficult for us, or we may not understand specifically what they want, but if we just concentrate on the math that we did and we realize we're changing a percentage change, either increasing or decreasing, and we know how to do that, then we'll able to resolve and find out what our answer is. So I hope you found this video both helpful and informative.